So yeah, good morning for the second session of our online GIS workshop. And I think maybe some of you might have questions for Abdelmanem regarding the tutorials. So also you can give us your feedback quickly on the first session if you would like to, and if you have any further questions for Monam regarding the first session or the first tutorials you got, please let us know. It would be great now if you can also open your camera so we can just discuss it better.
Hello, everyone.
Hello.
I have a question. I still a little confused about the difference between ArcGIS Pro and ArcGIS Online. Some of the tutorials were for ArcGIS Pro and the last one for the ArcGIS Online. So when we decide to use each software,
well, it's not when do you decide. It's think of it like this. We have a desktop application for us that we work on. We do most of the work on that desktop application, managing the first start with the data.
sorry, I lost the.
Yeah, Abdelmanem, I think he got frozen.
Okay.
The video froze. However, till Abdelmanem comes, Rowan, the ArcGIS Pro is a desktop application. It's connected to the cloud for the ArcGIS or for the Esri cloud itself, where you can upload your files, your documents on the ArcGIS online. You can share it with the whole group. Either you can edit it online, you can publish it directly using other applications from Esri Enterprise, like the story maps or the dashboards and so on. So all of these things you can do using like the ArcGIS Pro when you just upload your documents on the cloud, so you can use them on the ArcGIS Online. However, ArcGIS Online, you can receive data from online sources that Esri made them available. It's the same like ArcGIS Pro, but the ArcGIS Pro has more functionalities, more capabilities of running analysis that you cannot run it on the online software. So the online software, it's not a software. On the online cloud, you can use, I don't know if you remember what Mona mentioned last time about the Jupyter Notebook, the writing the codes. So you can write codes to run some functionalities online. However, it is still limited. It cannot run all the functionalities that you need to run it when you are using the ArcGIS Pro on your desktop. So on your desktop, you have more capabilities, more functionalities that you can use and run in that sense. You are muted, Abdelmanem.
Sorry, I dropped for a second. Okay, as I was saying, the idea with moving into ArcGIS Online is actually having more or different options, I would say. So sharing maps or data online with our colleagues, since we have our content, and there is a tab for the organization where we can also have data that is shared between all of us there. We can work on it, download it and work on it on ArcGIS Pro, or work on it directly on ArcGIS Online. But then if you want to create dashboards or create storyboards, that would require us to do that on ArcGIS Online. It gives us tools to create more exposure and certain products for our products. Okay, so they are not competing softwares.
Yeah, I got it.
So to speak. Okay, they're not competing softwares. They are they should work in tandem.
Yeah, like the ArcGIS Pro for the major work or the starting of the work, and the ArcGIS Online is for sharing, publishing, and presenting in between brackets.
And also we have this ability to create apps. Maybe we didn't talk about that, but we have the ability to create apps that we can share also with others. They have this. Maybe I'll share a tutorial on it or something with you. They has this ability that
Yes, I have made this tutorial.
yeah. The ability to create apps, and it's already designed. The system is already designed, so it's not requiring us to or those users to know to be a programmer, developer, or something like that. Makes it much easier for us to create maybe a mobile app or a desktop app that is used by others in the field or on their desktops for more activities or something like that. So we also have that option. So those options all come from the ArcGIS Online. Okay, so this gives us this opportunity to do those sort of stuff.
Okay, thank you.
You're welcome.
Hello, my name is Mahidab. Can I ask a question?
Yes.
I'm working now on QGIS. Can I import my file in ArcGIS Pro?
Yeah. QGIS works on most of the files that we use, so you can save your files as shape files and move them, and you can also, I think you can even use the file database. I think the last time I worked on QGIS, there was the ability to open file database files. I'm not sure if they can save files into file database. I think maybe. So moving files from one system to another is possible.
Okay, I have another stupid question, very stupid question. When I tried the tutorial, try to apply the tutorial, I can't find the content, I think. Content, yes. I can't find content. I can't start.
What do you mean?
You mean the content pane of the ArcGIS Pro?
Yes, where is the content?
It's the band to the left side.
I can't find it.
Maybe you need to open it from. You need to open it from the ribbon, from the windows.
Okay, I'm tried everything, but I can't find it.
Maybe it was closed. It was closed by mistake or something like that.
Maybe.
So
I can't find it, and I can't start it. Anything.
Give us a second.
We find that problem already, but you must go to ArcGIS Online.
No, I don't working on ArcGIS Online. I install the program from the links.
No, it needs ArcGIS Online.
You mean the first exercise, while the second...
Yes, the first exercise.
Yeah, it's online.
Ah, it's online? Okay.
Yes, using ArcGIS Online. And in case it's gone on the desktop, you can press on View. Maybe it's closed accidentally. View, and then press Content pane. Then it will...
Yes, there is an icon of contents, but I click on it. It don't give me anything.
So this is the contents pane?
Yes, on View, okay, in the top ribbon.
From View, you can, if accidentally it's closed or something like that, you can
I click on it.
Open it from, you can click on it here. Where is it?
Beside geoprocessing.
Yeah, but you can also reset bands. Sometimes you maybe move the bands someplace or something like that, so can you reset them? But you can just click on the contents band and it should be open for you.
I found it in view, yes, and when I click it, don't give me anything.
Then it might be still open. Maybe you've because we can actually move the bands, so maybe you've moved it to behind something or something like that, and it's sorry.
Abdulmanam, we can ask her. Maybe Mehtab, you can share your screen, so it would be easier. I can give you access to share the screen now.
Okay.
So try to share your screen, and we can check where is it on your laptop.
Yeah. You already have it.
Yes, the contents is already there.
Yes. When I click, don't give me anything.
Yeah, this is the content. The one you're hovering on. This is the content. This is the content span, but you didn't load any layers to it, so it's empty. It has only the base map.
Okay. When I can find the living atlas on it, how can?
Living atlas?
Yes.
I don't think I gave you any exercise that used the living atlas on the ArcPro.
No, the first
thing
one
was in ArcGIS Online. This is the one that used the living atlas.
I
In
can't.
ArcGIS Online, when you log into www.arcgis.com,
Yes.
you use your username and password that you got from Castle University, and once it loads the main in the main browser, you have contents. That's your contents. It has nothing to do with this span. And then on the right side, you'd find Living Atlas.
I can't.
Atlas and you load it from there. So it's on the browser. It's not on ArcGIS Pro.
I can't use Atlas on GIS Pro.
We can, but it's but the exercise wasn't for ArcGIS Pro. The exercise was ArcGIS Online.
Okay.
No, if you need to use it for Pro, you just go to the geoprocessing. You have that portal tab in the geoprocessing, and then you can start loading.
We can check it later, but I think the most important thing is that you follow the exercise, and the exercise was for ArcGIS Online. It wasn't for ArcGIS Pro.
Okay. Another question. In QGIS, I'm using OpenStreetMap to edit or upload any map. Can we use it in ArcGIS in ArcGIS Pro?
You want to have an access to OpenStreetMap?
Yes. Can we?
Yeah, to some extent, you can load something from OpenStreetMaps. It has workarounds, but yes, you can do some work from it.
Okay.
One of the base maps that we can use is actually an OpenStreetMap base map. Capturing data from OpenStreetMap is another issue, but it's also doable.
Sure. Thank you.
Yeah, you're welcome.
Anyone else has questions?
Can I ask a question?
Yeah, please, Dina.
In tutorial, ask me in ArcGIS Online, in which two ways can you add a CSV file to a map to visualize the location?
Say the question again.
In which two ways can you add a CSV file to a map to visualize the location? Sorry.
Okay, which exercise was that? The one?
Two.
Sorry, just a second. Okay, and you want to add?
I remember from add menu, choose add layer. That's right.
Yeah,
but
you can
I
add
don't
data
have
from there.
the right answer.
It wasn't the right answer
It wasn't the right answer.
because it's not add layer. You don't. The CVS is not a layer; it's a table. CVS files are table files. They spreadsheet files. They look like they're not, but they look like an Excel file. So you can actually load them from your ArcGIS Pro system. Since we can upload data to our content, you can go to your content, and since in your content is actually asking you to what data you have. If you want to have more data, you can add it from there. And once data is in your content, you can actually import it to any map you're working with.
Yes.
This was in the quiz, I think, right? The quiz.
Yes.
Yeah. I think the quiz is one asking about that. Yeah, but you can't add it. It's not a layer file. See, if you say add a layer, layers are layer files, and those
Not
are
layer
something
from
that we
file.
have that has the symbology of the maps stored in it. It has nothing to do with CVS files.
Yes.
So it will not work. So that's why this is the wrong answer.
Yes. Thank you.
So who else has questions? So if everything was clear and you don't have further questions, we can proceed with today's content. So do we proceed now, or do you still have questions?
I have a question, please.
Yeah, please, Ayat.
When I input to links about exercise and quizzes, tomorrow it's open, but now it's don't open. Can I share my screen?
Yes, I will give you access to share your screen. Yeah, please. Can you click on the link
this
again?
message? Yes.
Or copy and paste the link, because maybe there's something.
I refresh it, but again, it's next this message.
I will check now because I sent you the links. I will check.
I had the same issue, but you can just reload on another tab and it will work. They may tell you that to start over, and you can press start over, and it will get you back where you stopped. It's fine. Yeah.
Okay. Okay. Okay, thank you.
Okay. So
I have a quick question.
yeah,
Just
please go.
regarding the first exercise, they asked us to download the data, whereby they said that it must be stored in Esri Academy on the sea, but we didn't use it. We didn't use the download. We searched for the data on the online platform. Can you understand my point?
You didn't use the data?
We used it online. we asked online for the layer. We copy paste the requested layer online, and then it loaded online. So
there was a file that you had to import to ArcGIS Pro. That's a different exercise than the one
no,
on
in
the
the first
website.
exercise. I mean in the first exercise, not the second.
Yeah, I remember
One that
using
is
it as
basics
well.
of ArcGIS, basics of GIS.
So I just was wondering, what is the Esri training C folder?
No, it's just a folder you create.
Oh, I created my own. Okay, it's not on the
usually in
yeah.
most Esri trainings, they will ask you to create a folder on the C drive, Esri training,
okay.
work with it. You can put it anywhere you like. For myself, I always put it on the D drive or the E drive, but Esri don't know how many drives you have on your device, so they take the safest path. So it's C drive, Esri training, and put whatever the data that they downloaded in there, and you work from there. So you just take the safest path.
Okay, great. I just a question that I was wondering if it was on online or something. It's on my desktop. It's fine. Thank you.
No, for every exercise, usually they will ask you to download some data to work with,
sure.
and usually it's always the same. They will always give you the same path. Just go to make a folder on C Esri training and put the data on it, or extract the data in it, and start working from there. So it's typical to all the exercises.
Okay, thank you.
Yeah,
thanks.
So any further questions, or can we proceed now?
I have a conflict between the ArcGIS Online and the ArcGIS Enterprise.
Okay.
The two are web GIS.
Enterprise is a license.
Okay.
And it offers you web, yes, but think of it like this. ArcGIS Online is on the Esri servers. So Esri has its own servers, and they have deployed ArcGIS Online on it, and you can do all the different functions that you saw, or some of the functions that you saw in the exercise, and more through it. But one of the main issue is when you do those exercises is that you must have data on it, whether it's in your contents or you find my contents, my organization, and so on. And basically, you have to have your data there to run any exercise, barring the ones that you get from the Living Atlas or something like that, or a similar repository from Esri. Now, this might, for many organizations, this might cause some form of a security challenge, since data is expensive and data is also private and might be property of one entity or the other, and they don't give you permission to just put it online. So the other way around is go to ArcGIS Enterprise, you buy the enterprise license, and you have your own servers or your mainframes, private ones, and you deploy the ArcGIS Enterprise on them. Once you made that, you basically have something like a private ArcGIS Online. Now you can log into that, you can enter that, and it's not the ArcGIS Online under Esri. It's something private to your own organization, and you can do all the tasks that you do on ArcGIS Online on this Enterprise Edition. So it's what gives you some form of a privacy. It's something for your own organization. So no individuals will usually buy an Enterprise Edition. It's a university or a government organization or a company that will have its own enterprise license deployed on its own servers or mainframe or data centers.
Okay, got it. Thank you.
Yeah, well.
I think now maybe we can proceed, Manam, with the presentation from today, and then maybe after, if anyone has questions, maybe we can ask them later afterwards.
Okay, just a second. Okay, can you see my screen?
Yes.
Great. Just a second. Okay, for our second session today, we're going to tackle some points and issues that are considered fundamentals of any GIS system that you will work with. Okay, just the first thing we will talk about is about what happens after capturing data. If you recall, last time we were talking about the main functions of GIS: capturing, storing, querying, analyzing, and display and output. One of the very important issues that comes to us after gathering all the data that we have is how we're going to store this data. And the decisions we take there will affect a lot of our work later on. The main thing we have is, are we going to store the data as vector or as raster? And this also comes with its own issues, like what are the geometries, how would the attribute look like, and are there any behavioral rules? Okay, as I said, this is a very fundamental issue, and we're going to tackle it one point at a time. So let's start first by the idea of vector and raster. As I spoke last time, vector data and raster data differ greatly from each other in the amount of data they store on the system. In vector data, it's more simplified. It's segments that has its own XY data, and to each segment or each polygon or each line, we have a record on the attribute table, and that's it. On the other side, raster formats don't deal in segments, it deals in pixels, and as we said, those pixels we call in the in ArcGIS or in GIS in general, we call them cells, and each cell has its own record in the attribute table. And as we have higher resolution data, we'd have much bigger amounts of data stored on the system. Some of the analysis that we have to take can only be run on raster, while other analysis can only be run on vector. So we have to have a decision made based how we're going to store our data. So we're going to explore now the types of what is vector data and what is raster data. So we'll move it one step at a time. So first, when we talk about vector data, we have basically 5 types. We have the points, the line, the polygons. There are some types of that as well, subtypes, but it's point, line, and polygon. Those are the basic vector formats. We can also store annotation, which is a form of labeling, but stored in its own feature class. So we can have a feature class that is called annotation feature class, or we can have 3D multi-patch, which allows us to store data that looks like the facades of buildings and 3D modeling of it. That also is something that we have the ability to do. We'll focus more on the main 3 types: the points, the line, and the polygons. When we say point, line, and polygon, we have the single part and the multi-part. Single part means that whatever feature we draw is only a singular feature that will have a singular record in the attribute table. So this point will have only one record in the attribute table. The segment of line will only have one record in the attribute table. And this one polygon will also have one record in the attribute table. Multi-part is a bit different. For example, here we have 4 points that are white and 3 that are red. Those 3 in the entirety will only appear in the attribute table as one record. So those 3 points will appear as one record in the attribute table. The 4 white points will also appear as one record in the attribute table. We can have the same in lines. Those are, for example, here we can move with the vertices of the line, and we can see this is one segment, second and third segment, but all the 3 segments will appear as also one record. We can also see it in the polygon. Those 2 polygons appear as one record. Now, why do we have something like this, a multi-part and a single part? Single part is easier to understand, but multi-part is the one that might be confusing. So let's take an example. For instance, if we're talking about an archipelago, let's say for example, like Indonesia. Indonesia as a country is a group of islands, and maybe several hundred islands or several thousand islands that are close together. Some islands are big and they have names. Other islands are very small, that they only have a coordinate positioning. It exists in XY coordinate and that's it. But if you're drawing a map for the entire country, you'll have to do all the islands. Now think of it, we are making a map for Asia, and we are showing all the countries of Asia, and one of the countries is Indonesia. Now we have to draw all the polygons that represent the islands of Indonesia. If we draw each polygon as a single part, this would mean that every island of Indonesia will have to draw it and then go into the attribute table and have a record that says Indonesia, and then move to another island, draw it, and have a record in the attribute table that says Indonesia. But they're all the same thing, and we're repeating the record for no use. So what we'll do in this case is, now we're going to draw a multi-part. So the entire thing will be drawn, all the islands of Indonesia will be drawn together, and they will appear as only one feature, as if they are only one feature, and we'll have only one record that says Indonesia. Now, if we change the scale, we're not looking at Asia, we're only looking at Indonesia itself. We're making a map for Indonesia itself, and we're zoomed in, and the only thing we see is Indonesia. Now we'll move to a single part, because every island has its own name. We don't have to write Indonesia in each record. No, this is Sumatra, this is Bali, this is so on. I mean, the names of different islands. Each island will get its own name in the record, in the attribute table, and it will have its own record with its location, its area, its circumference, its main cities, and so on. So this makes the difference for us. So usually it's a decision we make while working. Are we working with single part, or are we working with multi-part? So that's one facet for the vector format. Another facet is how the vector formats are oriented. How do we give them a coordinate system? Usually they all have an XY. So whatever we're drawing, a point or a line or a polygon, there are vertices, and the vertices will get an XY. We can also have some extra data, which are, in some cases, we have something called the Z value, and in other cases, we have the M value. The Z value is usually clear. We all know what the Z value is. It's basically the elevation. So if we look at this section, so to speak, this point is at a height of 40 meters, while this point is at as a height of 1020 meters. So this will be the Z value. and if I add Z value to my points or vertices, basically the data will have a 3D factor to it. And we have some data that comes in this format. Sometimes all our data is XY, so it's only 2D. And sometimes we have data that has the Z values to it. And so it becomes formally a 3D type data. The M value is another one that we have. It has nothing to do with 3D. It's more of a measuring system. So if we look here, we have also the y-axis and the x-axis, and we have this segment of line starting from this point and ending at this point, and those are some of the vertices of the line. Now, how do we attribute those vertices? How do we place coordinates to them? We use x, y, and m. Now, let's put it like this. The xy of this point is actually 2x and 5y. So it's 2, 5. And then we have 28. What is 28? 28 is basically the measurement from the start of the line to this point. So it's basically from the start of the line, here is 0, and this are 28 units. So this becomes 2, 5, 28. Now, the next point will have its own x and y, and also the measurement from the 0 till here, which is 68. The next one will have the measurement, which is 101. This becomes 248, 294. So we're actually measuring along each line feature. Okay. Quite frankly, I haven't used that ever. I never got any data that has this, but sometimes you will have its uses. Z factor comes a lot. It depends on how you're getting your data, but in our work, where we have to work with the maps for urban environments and so on, finding data that has Z value might be very important. Okay, this is just putting to the idea of abstracting the data.
Abdelmanan,
yes.
Just Eva is saying,
questions?
Yeah, Eva is saying I'm a bit confused about the M value. I thought it would be confusing, this section.
It is confusing. It is confusing. I can't say it's not.
So she is confused about the M value. So if you can explain.
I don't have a particular question. It's just that I just don't understand what is the M value basically, because it seems as if it's interaction between x value and epsilon value. But what is? I don't understand it. Yeah, maybe
it's a measurement. We are actually measurement along the feature itself. It has nothing to do with the x and y, because if you check it like this, x and y is where something is in the x axis and what's on the y axis or the epsilon axis, that's xy. And then we have a measurement along the feature itself. So let's say that this feature from this feature line is from this point to this point is 300 meters. What I'm actually doing is saying that this point, this vertices and this vertices and this vertices is how long along the line feature itself. So this one is 28 meters from the start of the line. This is 68 meters from the start of the line. This is 101 meters from the start of the line.
Yeah, I get it now. Thank you.
So we're basically measuring something from the start of the line itself. So in the field, if you don't have an XY coordinate, but if you're measuring the actual distance from the start to your point that you're standing in, you can simply say, I am this far along the line. And that's it. You have it like this, and this is the M value. Where I say that I have never experienced it before, I think people who are in surveying or people who have geography oriented discipline might find this, because they already they have a lot of ground control data and so on. But in the urban and planning context, urban planning context and regional planning context, I never actually got data that had M values in it. So it's not something that is common in our field, at least.
Okay,
That's why, from my experience, I mean, in our field, I don't find it, but finding something with a Z value, that comes a lot. It actually says that the data has higher quality. If it has not just X and Y, but also have the Z value, this is of higher quality and open options for us that we didn't have before. Okay.
Yeah. Thank you for the explanation. Now it's clear.
Yeah. Okay. When we are working with the data, now we have we're starting to make this vectorization. And
sorry to interrupt, but
yes.
Munir has also another question. Would the M value be constantly the same between M1002 and M248, since it is a straight line, or is the measurement independent from the graph?
Again, say it again.
Would the M value be constantly the same between M101 and M248, since it is a straight line, or is the measurement independent from the graph?
I don't understand the question.
I think
those points have different
M values,
values, because it's how let's say this is 101 meters from the start of the line, and this is 248 meters from the start of the line. And if we're talking about the XY, they have different XY data for them. So there is no constant here. Everything changed.
Is it clear now, Munir? Okay, so we can proceed.
Okay. Okay, moving to the next point is about abstracting the reality. As we said, well, maps in its entirety are a form of abstracting reality. We're trying to make a simplification of reality and put it down on a map. Right now, this is not a map. We're talking about GIS systems, but it's the same. We're trying to simplify reality and add it to our databases. Now, how do we make the decision? What will be a point? What will be a line? What would be a polygon? That depends basically on the level of simplification we have, the scale of the maps that we want to produce later on. Are we talking about very detailed maps that are 1 to 500 or 1 to 1000? Or are we talking about more of the generalized maps that is 1 to 100,000 or 2 to 150,000, something like that? Those generalization, when we're talking with vector data, gives us the idea of, okay, how are we going to represent the different features? And are those features going to be represented also? This could be the question. So, for example, in this this example here, we have this photo. This is an area. We have a street here. We have some land parcels. We have there are some trees and so on, some features and so on here. When we simplify or abstract this this map into a vector, we first try with the streets. So we have all the streets as lines. They have no place being drawn as polygons or something like that. No, they are all drawn as lines. The land parcels themselves come here as polygons. We can already see all the parcels. So we start drawing them as polygons. And what did we place as points? We placed the main stores. Maybe there are some stores here on the street. So we're placing a point to show where those retail stores are. But for example, we could have added the trees, but would it be useful on that scale and this much trees? Would it be useful to go and add a point for each tree? Maybe at a higher scale, if we have more zoom in on that, we're making a map that is 1 to 500, or maybe even a lower scale, 1 to 100, or usually we don't use that in the urban context, but 1 to 500 is a scale that we use a lot. We might actually add data for the trees itself. So you'd find each tree as a point. But if we move higher, so we're talking that, we are making maps that are 1 to 1,000 on the scale. Adding points for the trees or for the lamppost or even for the retail stores might make no sense at all. We might actually start adding points that have to do with main landmarks or main monuments in the area we're dealing with, or for the train stations or for the metro stations. So we have change what can be what would appear on the map and so on. So based on the level of details that we want to show on the maps, we make the decision, are we going to use points or lines or polygons for it. One of the very famous examples is if we're looking at a map for the entire country, any country, and it's a map for the entire country, and we're placing the cities. For a map for the entire country, the cities will be placed as points. We can draw cities as polygons when we're talking about the entire country. Country is usually several thousand or maybe million or more square kilometers. So drawing the cities as polygons it doesn't work. What we do is place points where the cities are and enter its data. But if we are zoomed into a small region, a county or a governorate or something like that, a Bundesland or something like that, and you find, okay, the area is much smaller, and we start drawing the outline of the city itself, the outline of the urban fabric of the city, and the cities start to appear as polygons. If we zoom in more and we start to, okay, this is a database for the city itself, the outline of the urban fabric doesn't work anymore, and we have to start drawing blocks, either the super blocks or the actual blocks in the city. And if we go more into details, we might start not only drawing the blocks, but actually drawing the buildings. So each individual building would be featured in this database. So it depends on the scale. What are we going to show, the details, and which type of vector data we're going to use. Now, this is one point. The second point in using vector data is how we are going to group them together. We said before that we have something called feature class, and that the feature class can only be of one thing. So we have a line feature class, or we have a polygon feature class, or we have a point feature class. But even when we say it's point, line, and polygon, the substance of a feature class or the subject of a feature class is also controlled. So when we say, for example, I want to make a feature class about the streets. So this is the part of the city, and we're making a feature class for all the different streets inside of it, and it's only feature class, we call it roads, and inside of it we are dividing the roads between based on the hierarchy. So I have primary, highway, and secondary roads. That's it. But I can come to this feature class and say, okay, I'm going to add train tracks. Train tracks are not roads, they are lines, but they are not roads. Train tracks have different data. They are not primary or highway or secondary. They have different data. It's this is a line for freight trains, or this is a line for passenger train, or this is a mixed line. It carries freights and passenger. This is a line for mines or factories or seaport or an ocean port or something like that. So the data between the roads and the train tracks are totally different, and we can't actually put both of them in the same feature class. We have to have a feature class for roads and another feature class for the train tracks. So this is a form of differentiation that we have to have for our feature classes. The feature class must have the same subject. The elements inside of it must have the same data. they have to be, the data must be common between them. So this is the type of the data, for example, for the roads, which is the hierarchy of roads. So all of them share a hierarchy of roads, where, even if they are at a different hierarchy, but the commonality between them is the hierarchy of the road itself. Okay, so this was some main points about using vector data. Let's move on to check on raster data. Now, there are many types of raster data. We can find ourselves talking about a satellite image. This is raster data. We might find that we are talking about what we call a classified map. In this classified map, you can see the colors. So the brown here is agricultural land. So any brown patch here is agricultural land. The green are actually forests. They are deciduous trees, deciduous pine or pine trees. The gray is actually the urban areas. The blue is the water, and the yellow is some barren lands. So this is actually, we classified the data, and we call those discrete values. We call that a discrete map or a discrete raster image. Each cell has a discrete value, and they form into those patches. They form into those patches, and we can read it as a normal map. Or we can have something like this. This is actually a height map. Height map means this map shows elevation, shows the Z value of the terrain that we have here. The white parts are the highest areas of the map, while the green ones are the lowest. And we see how the color degrades or degrade between one color and the next. And actually, in the attribute table, if we check the attribute table, since those are Z values, what we will find is that each cell has actually a number that is actually denotes the Z value of this cell. We call such a raster image continuous data, since basically from one cell to the next, all the difference is a number. From one number to the next, from one number to the next, and so on. And then we can show it on the maps. And usually when we show it on a map like this, we show it in ranges. So not each cell will get a color, but each range of data, let's say, for example, the ones here that show in white are actually all the elevation that is between 1,000 meters to 1,500. Anything lower than 1,000 meters will start to get this violet color. And then as we move, for example, below 500 meters, they start to show this orange to yellow color. And then we go into the green for anything that is lower than 30 meters, for example. So it actually divides the map into ranges, and we only see that stretch of ranges in the visual representation, and we call that a continuous map, or a continuous map, or continuous image, raster image. And of course, we can have a normal raster that we all know about, an image, a direct image of an object, and we can also store that, by the way, in the database. So all of those can be stored in a database in one way or the other. So when dealing with raster data, first of all, the raster data we're going to show or shows as a grid, and that grid is divided into cells that carry a value or the attribute that we're studying. There are some native formats from Esri, like the grid, still exists, but there are also images like the TIFF, BMP, SID, JPEG, and ERDAS. PMB and TIFF, you all know, on JPEG, you all know, because they are used in many graphic programs. ERDAS and SID and something called GeoTIFF are actually used to store satellite imagery. So we can use that as well. Okay, the idea of the grids. This is how we actually view raster data. This is the raster data map we have, or the layer we have, raster layer we have. And this raster layer, if we zoom in, is actually divided into cells, and each cell will have its own value, its own data. If it's discrete, like this looks like, this is discrete data, so we might be saying, okay, this is a deciduous forest, and this, for example, are pine trees. Those are urban areas. This is water. If it's continuous data, you probably have it as numbers. So we only have numbers here, and it will represent something like the elevation of the land, the temperature, a degree of the spread of a contaminant or something like that. Raster data, of course, will come with a raster resolution. And how do we calculate this raster resolution? It's basically what we call the cell size. The smaller the cell size, the higher the resolution that we have. So if we look at this polygon here, let's say this is a polygon for a pond or a small lake, and we're turning that into raster data from vector data from a polygon. We're turning that into raster data. The higher the resolution, the smaller the cell size, the more details we see that resembles the vector data. The rougher the resolution, the lower the resolution, the bigger the cell size, the more rough the details looks like. I mean, the resemblance between this and this is, I mean, it's getting lower and lower. But if we move here, when we have a much bigger cell size, a much lower resolution, there is no resemblance actually between the two. Now, why do we use that? As I said, the higher the resolution, the more the data we're storing. So if you check here, we have something like 60, 70 cells that cover the entire bond. Each one of those cells carry the same data for the bond. While if we check here, those are 5 cells, and each one carries the data that we were storing for the bond. So we're comparing between a situation where we are storing 60, 70 cells, and this here where we're storing just 5 cells, just storing the data for 5 cells. The difference is huge. And when we're running an analysis, the time it will take to run the analysis is also huge. Of course, it's not only a factor of the time, it's also a factor of the accuracy of the results. When we are running an analysis, the more data I wouldn't say the more data, because some people will think like this. The more data we have, the more accurate is our results. Actually, that is not entirely correct, because depending on the level of data that we have and the type of analysis we're running, at a certain point, if you have more data, it does not translate into having more accurate results. Just having more data will not give you more accurate result. It will just take more time to compute, but it will not give you an accurate result. So usually there are tests that we run when before running an analysis on raster data about the most optimal cell size and raster resolution that we should work with, that would give us the best results of the analysis. So there are some usually statistical tests that we have to run to say, okay, optimally we should work with this raster resolution. This will give us the best results. Any more than this will not contribute to a higher accuracy of our results, and lower than this will actually give us much lower accuracy of our results. So there is some form of tests that we run to do that. Now, we say that the grid is actually, usually when you check the grid for the raster cells, it's usually in a square, but that's not the only form. It could be in triangles, squares, pentagons, hexagons. It might not be uniform. As you see, all of those are uniform shapes. No, it could be in a bit of an, for the triangles, for example, it could be a bit of irregular shape, not equidistant like this, and so on. So it could be somehow irregular in its form. It also works with us. So there are different shapes, and we use them as we come by. And how do we store the data in them? Usually each cell has its own unique data, and then we see how we're going to represent that data in a visualization later on. Okay, so this was the raster and the vector data. Do we have questions before we move to the next part? Hello.
No.
Any questions before we move to the next part?
Is everything clear?
Yes, everything's clear. Thank you.
Okay. Okay, we're going to actually have maybe 5 minutes rest after this slide, because it starts not a whole new topic, but a continuation to the topic. This is the vector, as we said. If you remember the first slide, we were saying, okay, we're going to choose between vector and raster, but there are also some component to that, which is the geometry, the attributes, and the behavior. Now, let's start with the behavior, because we won't have slides on that. It's really a very big topic, and I'm not sure it's good for the crash course, so I haven't included it, but I will just give a short introduction to it. Behavior is actually attributing rules to whatever we are creating in the database, whether it's in the vector, or whether it's in the spatial representation or in the attribute table. So as the example here says, for example, streets and highways may not intersect. This is a rule that is placed on our data. So if we are working with a feature class for roads, and by some mistake, whoever is editing the data, you're drawing a street, and the street somehow intersected with the highway, you would get a validation error. It will tell you that there is an error in this area, and you'd have to check it to see, okay, I made a mistake. There should have been a cul-de-sac at the end of this street, so it actually does not intersect with the highway, or this was actually not a street. This should have been a primary road. So a primary road could connect to the highway, but I made a wrong entry in the attribute table, denoting it as a street or as a local street, and so a mistake was made in the attribute table. So this is actually what we mean by behavior. So it could be something like this. It would be something like we have parcels and we have streets. We have a feature class for the parcels and a different feature class for the streets. And as a rule of thumb, parcels and streets do not cross each other. They move in tangent, or they are parallel to each other and something like that, but they do not cross, they do not intersect. So if I'm drawing and somehow a road intersects with one of the land parcels we have, I would also get this validation error that there is an error here, because this piece of land, this road is actually crossing the street or intersecting with it. You have a mistake here, and you check it and see where did the mistake come from. We have also some rules to the attribute table itself. We can restrict certain fields to a certain set of values. If you want to work, if you want to enter any data in this field can only accept a certain set of values. Let's say, for example, the example for the streets, we're saying we're only accepting local streets, primary, secondary, and highways. You can get, for example, and someone is entering data and you write Autobahn. It will not accept that. It will only accept you writing highway. Autobahn doesn't work with it. It was not identified to work with that. And this actually preserves what we call the integrity of our data, because in data entry itself, if you have several people entering data, or even one person, but he's entering several thousand records, for example, by hand on the computer, and they make a spelling mistake here, or they with a lot of work or something, there's a moment of confusion or a lapse of memory or something like that, and they make an entry that is not right, that is not wrong. When you get this idea about okay, this is wrong, this is the wrong entry that you made right now, it gives you, hey, you can't accept this entry, so we preserve the validity of our data using that. So those are what we call behavior rules. The other thing we're going to talk about is geometry, which usually deals with the coordinate system that we use for all our data, which spatial data must have, and the attribute about how the anatomy of the attribute looks like and how it deals with. So maybe we take a 5-minute break, and when we come back, we'll start talking about geometry, and after that, we'll talk about the attributes. Okay?
Yeah. Thank you, Muna.
Is everyone back?
Yes.
Yes, we're back.
Yes, we're back.
Okay, the next topic we're going to speak about is just a second. I think there is a mistake in something here.